In this video, I'm going to look at some of the problems on the 8.3 worksheet. A couple of the theorems that we need, chords, and the arcs that they create. So if the chords are the same length, the arcs have the same degree. You're going to hear baby noises in the background. So this isn't talking about the length of the arc. It's talking about the degree of the arc. So the degree of the arc is going to be the same on both of these if the chords are the same. And the chords will be the same if the arcs are the same. So that's what we're going to use in this first couple problems. So this right here is telling me that the arcs are the same. So if that's true, then I know that the chords have to be the same. Well, it gives me the length of this chord is 4x plus 10. That has to be the same length as that chord, which is 38. And then I can just solve for x. So I subtract 10. And I get 4x is equal to 28. Divide by 4. X is equal to 7. So that's a value that when I input this, I'm going to get 38 because they have to be the same length. 4 times 7 plus 10 is 38. Okay, on this next one, it's giving me that the chords are the same length. So if the chords are the same length, the arcs that they create, so if this chord, this is the arc, for this chord, this is the arc, have to be the same. Well, it's not telling me what it is equal to, but it is telling me it's an x. So this has to be an x as well, because they have to match. Then I can use what I know about the circle, which is that a full rotation of a circle should be 360 degrees. So I can take this 38 and then add this x and the x that it started with, this x, and that should give me 360 degrees. So then if I combine like terms, I get 2 x's plus that 38 is equal to 360. So I'm going to subtract 38 from both sides. 2x is going to be equal to 322. Now divide by 2. X equals 161. Now I'm going to look at a couple other problems. So give me a sec to kind of write those out. On this problem, it wants me to find the radius of the circle. Well, that's going to be this piece. Again, this is not to scale. If it's this piece, I can also say it's this piece, because from the center of the circle to the edge is going to be the radius. So that's what I'm finding. I think she wants attention. I'm going to actually not really even use a theorem on this one, just because, well, I guess I am. When the diameter or the radius goes through the center of the circle to the other side, it's going to cut this chord into equal parts. So whatever this is the same over here. But more importantly, it meets it at a 90-degree angle. So this is 90 degrees. Well, this piece right here is saying that this is 3 meters. So this has to be 3 meters and this has to be 3 meters. I don't really care about this one. because I have a right triangle here. Sorry, guys. So I'm going to redraw this triangle where it's that 3 meters, 3 meters, and then I'm trying to solve for that x. A couple ways you can approach this. You can do the Pythagorean theorem. Side squared plus side squared equals the hypotenuse squared. Or you can see that this is a 45, 45, 90 triangle because the two sides are congruent here. And so then to solve this, you just multiply by the square root of 2. So either do it that way, or I'm going to set it up as we're going to take side squared plus side squared, and that has to equal the hypotenuse squared. Remember, the hypotenuse is always across from that 90-degree angle, and that one has to be by itself. So I get 9 plus 9 is 18. So 18 is going to equal x squared. And then you take the square root of both sides. Remember, taking the square root is going to undo that squared. And I get the square root of 18. Now, if you get that as your answer, that's fine. I will take that. I would like you to try to simplify that radical. Remember, we can break apart square roots. So to get 18, I could do 9 and 2. And then I know what the square root of 9 is. The square root of 9 is 3. It no longer has a square root because the square root is what turned it into a 3. But with the square root of 2, I can't turn it into anything else, so it's just square root of 2. So if you simplified that, that would be your answer. Oops. Which still kind of maps up with if this is a 45, 45, 90 triangle, you multiply by the square root of 2, and you get 3 square roots of 2. So a couple ways to approach that problem. I don't really care how you do it as long as you can get through it. Okay. Now I'm going to do 13. So it looks like we have the center of the circle, we have a chord, and then we have something going to that piece, and then it also has the radius is 13, this piece is 5, and then it wants this entire length is x. Well, I know that because of this theorem, this is going to meet at a 90-degree angle, and I'm actually going to, I know it says there over here is 13, but it's just the radius of the circle. I can draw the radius anywhere I want. So I'm going to say, well, that's 13. So now I have a right triangle where the hypotenuse is 13, and this side is 5, and this side is not x, so I'm going to use an m, because x is the whole thing. So Pythagorean theorem says to take your side squared plus your other side squared, and that's going to be the hypotenuse squared. And so I get m squared plus 25 is equal to 169. Subtract 25 from both sides, you get m squared is equal to 144. Take the square root, and that's actually going to be 12. So what we found was that this piece right here is that 12. Well, it wants the whole thing, this piece, and our theorem says that when it meets like this, it splits it into congruent or equal parts. So if that's 12, that's 12 as well. So x is going to be 12 plus 12. So x is 24. Okay, on 17, I'm not going to do the whole thing, but I am going to get you started. So let's actually just turn this paper. So on 17, it says that the radius is 8 centimeters. It wants this whole piece, and this is 120 degrees. Well, I can know that if I continue that out, that's also going to be at 120 degrees because of the central angles. But if I cut it in half, like this, I get a right triangle, and now that's 60 degrees. So I'm going to redraw this triangle right here. So missing side, I don't know what this side is, so I'm going to say H for height. And radius, and that's a 60, which makes this 30 because that's 90. This is a special right triangle where I have the hypotenuse. So if this is the hypotenuse on a special right triangle, this is my short side and this is the long side. Sorry. I'm going smaller, so I'm dividing, and it's by 2, because if you look at, so 30, 60, 90s, that was our A value, 2A, and A square root 3. So divide by 2, that's 4. Multiply by the square root of 3, so that side is 4 square roots of 3. So we found that piece is 4 square roots of 3, and I'm going to let you find x on your own. You are so loud today. Are you being loud? Okay, and then I'm going to do one more problem. We're just going to turn this page, save in paper. I'm going to do 24. Oh my goodness. So, it says that this is, it's hard to see on yours. Hold on. Okay, so that piece is 2.4. And then it says that this piece and this piece are the same. Well, if this is 2.4, that's the radius of the circle, this whole thing has to be 2.4. Well, if that whole thing has to be 2.4 and it's being divided into 2 equal parts, each of those has to be 1.2. So this is 1.2 and this is 1.2. Then it says that, let me find a different color. This is 2.5 right here. And it wants us to find this piece right here, which is x. So this theorem is saying that I have to take not where the center is, but where the two lines are intersecting each other. So I'm going to take this x and multiply that with 2.5. And that is going to be the same as if I take, let's use orange, this piece of 1.2 and multiply that with the entire length right here. So whatever 2.4 plus 1.2 is, because if this is 2.4, 1.2. So when you add those together, you get 3.6. Can you still see this? Barely. double-sided. So there was kind of a lot of addition going on here, but basically I have 2.5 x is equal to whatever 1.2 times 3.6 is. So I'm not looking at the right problem. I think my answer key is wrong on this one. So yeah, 3.6. Yeah, that should be 3.6. So when you multiply those together, let's see what you get. I don't have my calculator out with me. Let's pull that out. Okay, baby, play with the lid. So we're gonna take 1.2 times 3.6. So 2.5x is equal to 4.32. Then you divide. So take that number and divide it by 2.5. So 1.728. Oops. Doing this one-handed now because of the baby. So that's how you would set up that one. That one's the most complicated one, is you just have to remember that you're taking that whole length. So this whole piece has to be multiplied. Okay, email me if you guys have questions, and good luck. Stay safe. Wear your seatbelt.